Welcome back, everybody. In this section, we are going to talk about sediment. So we talked about breaking rock down, the weathering process. Now we're going to talk about all those little pieces that come as a result. And sediment, first off, is kind of a broad term. It encompasses everything from these little tiny sand grains, all perfectly round quartz crystals, to the stuff that's a little bit more rocky, angular, to pebbles on a beach, all the way up to big angular boulders of rock. So let's say that you wanted to make something like this. Well, here's the recipe. You find a rock, break it down, lots of different ways to do that. You take those little pieces and put them somewhere else, and then finally you let them settle out, collect at the bottom maybe of a river or a lake. And the result is this thing called sediments. These are going to be rock fragments that have been fragmented, transported, and deposited as a result of weathering. But not all sediment is the same. Some of it is going to be the first thing you think of, your classic beach sand. You have physically, mechanically weathered a rock, broken it down into these tiny little sand grains. You put all the sand grains together and you get what's called clastic sediment. On the other hand, you imagine a totally different setting. We have an ocean with all these little microorganisms in it. And even though they're very small organisms, they have these hard shells look like this under the microscope. And when all these organisms die, they sink to the bottom, they collect in a pile of biogenic sediment. So bio like life, genic is like generated. So sediment that comes from life. And the final kind is going to be this chemical sediment here. Chemical how? Well, you imagine you have a different setting entirely. You have this salty lake bed, and water comes in and dissolves some of the salt. And then later, the water evaporates and precipitates that salt out. It leaves the salt behind. And as a result, you have this salty buildup. This is going to be chemical sediment. So you might imagine that you go to the beach and you take a little bit of the sand with you in a bag. And you bring that bag back to the lab, you stick it under the microscope and you look, and this is what you would see. You would see a bunch of little tiny grains. And in this case, we know our minerals. These are going to be little tiny rounded quartz grains up close, one of the primary constituents of most beach sand. This is a clastic sediment. And the way that you could talk about the type of clastic sediment here, you would say that we have round grains as opposed to like sharp angular grains. You would say that it is pretty well sorted, so most of the grains here are the same size. We don't have some small ones and some big ones. It's pretty uniform. And then finally, you would talk about the size. So are these giant boulders? Are these little tiny silt particles? Or are they somewhere in the middle like the sand? On the other hand, you might take something that feels like a chalk rock. And you look at it under the microscope really, really far up close. And you would see these little tiny things. Now, technically here, you would need to put this under a very, very powerful microscope. Things that can see like nanometer scale. Really, really small stuff. But you might see, for the right kind of chalk, these little things are called coccoliths. These little tiny balls that were once living organisms. Well, it means that that limestone is made out of biogenic sediment. It's going to be sediment that is composed of some kind of animal or plant or living organism's remains. But it doesn't just have to be little tiny organisms either, as we'll see. It could be a rock that's made out of shells or bones or wood or teeth or anything that was once living to be biogenic. So for our last setting, we're back to that dry lake bed. And okay, maybe it's not dry all the time. Maybe sometimes it has water in there, and that water has all these different minerals and salts dissolved in it. That water slowly evaporates, and as it does, the minerals and the salts are left behind, makes this buildup of chemical sediment. And this can occur on a lake, this can happen in the ocean, this can happen in caves, or wherever you have hot springs flowing out of the Earth's surface. And it's going to include things like halite, salt deposits, things like gypsum deposits, as well as travertine. Travertine being what happens whenever you have a hot spring that makes limestone. Okay, so we've talked about these three main types of sediment: clastic, biogenic, and chemical. But it's the clastic sediments that we're going to spend the most time on. These are usually the most important. And now, maybe you remember, we talked about the different ways that you can describe a clastic sediment. You have your grain size, you have rounding, and you have sorting. Let's go into a little bit more detail about what that means. So generally, the type of clastic sediment depends on the grain size and not what those grains are made out of. All we care about is how big the individual pieces are. So the biggest kind is going to be made out of gravel. In the middle you have sand, smaller is silt, and then really, really small stuff is going to be clay. So let's take a look. So we'll start over here, right? And this is kind of a ruler that's been blown up a little bit. It's a special ruler. And we have like 1 centimeter here, 2 centimeter, 3 centimeters here. Well, 3 centimeters is about the same as an inch. So this is an inch right here. And we can use this as a sort of sediment grain scale to figure out what kind of sediment we're talking about. Well, any time that you have sediment where the individual pieces are bigger than 2 millimeters, right, bigger than about that, it's going to be in the biggest size. It's considered a gravel. 2 millimeters or larger is a gravel. And 2 millimeters really is not that big. It's even smaller than it looks like on the screen here. And if it's in this range here, about 1/16 of a millimeter to 2 millimeters, it's going to be considered a sand. Everything from kind of a coarse sand that, you wouldn't necessarily want to mess with, it'll mess you up, all the way to the finer sand here. Smaller than that is going to be silt, and we're not going to worry about the exact numbers here, the measurements. We just know that sand is kind of in the middle. Finer than that is silt, and then clay is actually so fine, the grains are so small that you cannot see them with the naked eye. No matter what you do, you need a microscope. And this has sort of a different way of looking at it here. So everything that is 2 millimeters or above is going to be a gravel, and you might have these different kinds, right? You have pebbles, and then bigger than that are cobbles, like cobblestone, and then even bigger than that are boulders, the big rocks. Smaller than gravel is sand, smaller than that is silt, and then the very smallest stuff are clays. And just to illustrate one more time the difference in size here, this right here is like one piece of sand coming off the beach, one sand particle. And for reference, to scale, this would be a silt particle here. You'd say, it's maybe 1/10 the size, 1/20th of the size. And then this would be a clay particle down here. It's tiny even compared to a grain of sand. So first is grain size. That's the most important. But the next most important thing is going to be the roundness. Is it more angular little pieces, sharp things, sharp edges, or more round stuff like these that we see in the photo here? And now you can see also it has this word sphericity. It's like, how much is it like a sphere? This is going to be just like a sphere, but this one is also just like a sphere, but it's a really angular sphere. It's about how circular the shape is as a whole. On the other hand, this is rounded, but not very much like a sphere. Low sphericity. And this one is low sphericity and very angular. It doesn't look like a globe or a ball, and it doesn't look like it's very round. Finally, we can talk about sorting. So you might remember that picture that we looked at the very beginning when we were talking about clastic sediments where you had all those little sand grains up under the microscope, and you notice they were all about the same size. Well, actually, let's just go take a look. Right? They're all about the same size here. None of them are particularly big or small. That would make this a well-sorted bunch of sediment. Now, on the other hand, you can have something that looks more like this. This would be poorly sorted sediment. You have some really big grains in there, you have some really small grains in there, and they're all kind of clumped together. Nobody has come through and sorted this thing out at all. It would be poorly sorted. Okay, so we've made it through all of this. We can finally put it together here. Put it together, literally. We take a bunch of gravel, like we see, this gravel pile, and we put it together, stick it together, glue it into a rock, it becomes a conglomerate. Sand, the sediment, gets glued together and compressed and squeezed together with time and becomes a sandstone. You can have a silty mud, and this is not mud in a technical sense, this is mud like you're used to, regular mud, but it has silt particles, and you compress it together and it becomes siltstone. You take a mud with a lot of clay in it, you put it together, and it becomes mudstone, or maybe shale. Those two are made out of the same stuff. Okay, so what does the process look like here? We take rock, we break it down into sediment, and then we stick that sediment together. But there's kind of a step missing in between there, right? The rock comes off the mountain and it falls down, it's transported by the river, but where does it finally settle down and stop and deposit? That's what we're going to talk about in the next section.